Let us go to the result section and visualize the result. Just click in the result and click on the edit. CFD post window will open. It will ask for the permission. Just request license. So as you know, in the case of 2D, additional members are created by the CFD post. First is the symmetry 1 and symmetry 2. So if you can check here and try to visualize it, just click on the Z axis so that you can see the 2D view. Just click on the symmetry 1 and you can see here, this is your symmetry 1. Just uncheck it. Now we will plot our contour. First we will plot our temperature contour. Just click on the temperature. First click on the contour and click OK. And now here the location will be your symmetry 1 and the variable will be temperature. Just click apply. You can see here, as you move upward, the spreading of the temperature is more. As you can see in the top, there is more spreading of the temperature as compared to at the bottom. Why this is happening? This is happening due to the buoyancy effect. What is happening? When the air is in contact with the hot plate, it will rise up and it will carry a lot of heat, and as it moves to the upward direction, it spread the heat, and due to that you can visualize the spreading of the temperature more in a upward direction. So this is the reason behind it. Now if you want to see the velocity contour, suppose, so you can select the velocity and click apply. You can see here near the plates the velocity is more, and here due to the viscous shear is more dominant here at the middle, the velocity is low. So we will check what is the direction of the velocity in the hot plate side and cold plate side. So for that you need to go to the vector section. First uncheck this and go to the vector section. Just click on the vector, click OK. Now what we will do, in the geometry section, it is all domain is selected. In the location will be your symmetry 1, and in the color section, in the sampling section, you need to give the face center, and in the color section you need not to do anything. Symbol you put just arrowhead. So here is your arrowhead, and size you can keep it minimum size and just click apply. So if I zoom in, or I can scale it, so just go to the symbols and just increase the size a little bit so that you can see here. Just zoomed in and I will show you. So you can see here the velocity, this is the velocity vector. So velocity is upward direction due to the hot plate. When the air is in contact with the hot plate, its density will reduce and fluid will move to the upward direction. And in the cold plate side, the velocity direction is a downward. And so that this kind of circulation is developing due to the buoyancy effect, and that circulation is responsible for the heat transfer in the natural convection. Next, we will plot our temperature, density and velocity variation. So for that, just uncheck this and create a line. So select the location. In the location, select the line. Here is the line, and in this line we will draw a line in x direction from the middle. So this is a point 1. So point 1 will be 0, and by coordinate will be 0.04, because we want to draw a line in the middle. And the second point will be 0.02 in x direction, and y will be same 0.04, because we want to draw a horizontal line. And now click apply. hopefully you will see a line. So here it is 0.02, or it is 0.2 only. It is 0.4. Yes, it is 0.4. Yes, it is 0.4. Just click apply. Now you can see here a line is drawn, and through this line we will plot the velocity first. So go to the plot section. Here is the plot section. Just search the plot section. Here, this is the chart section. Go to the chart section and click OK. And you can change the title also, but I'm keeping it as a default. X-axis, you need to choose X, and Y-axis you need to choose velocity in the Y direction, because we want to track the velocity in the Y direction. Just click apply. It is saying that location is missing, so you should give the location properly. So go to the data series. In the data series there is a location option. Just select the line one and click apply. So now you can see the velocity profile. Velocity is increasing near the hot plate, and then gradually it is decreasing. So this is the basically variation of the velocity. Simply you can also plot the pressure and density and temperature also. So let's say I'm selecting the temperature, so you can see the temperature variation. At the hot plate temperature is 12 degrees Celsius, and at the cold plate temperature is 2 degrees Celsius, and temperature is varying linearly from the hot plate to the cold plate. So this is the basically the variation. So similarly you can see the density variation also. So here you need to select the density also. So you can see here at near the hot plate density is low, and when you move towards the cold plate the density is high. So this is basically a result analysis, and next lecture we will evaluate the heat transfer, and through that heat transfer we will calculate the Nusselt number. Thank you.